Hello and welcome. In this video, we're going to be continuing our Introduction to Differentiation series, and today we're going to be focusing on solving and only solving questions that are related to applications of differentiation. So, if you haven't watched the previous parts, I'd encourage you to go and watch them so you have the enough knowledge and tools in order to differentiate. And then here is basically what we gain from differentiation, what we use differentiation for, what we use differentiation for. So this is super important for all engineering people that want to pursue engineering. That's how useful differentiation can be. So let's start by looking at the first question. So it says, the diagram shows a sketch of a curve y equals x squared plus 3x minus 4. So it's given us the equation of the curve. It says differentiate y with respect to x, so this is super easy. If I want to differentiate, I know that y dash is going to equal 2x, I'm differentiating this, plus 3. So this is my differentiation. And then it says, find the equation of the tangent to the curve at the point 2 and 6. Okay, so let's say this is 2, so the point 2 and 6 is over here. Okay, so this is the point 2 and 6. The tangent to this point is going to have something, is going to look something like this. Okay, so this is the tangent at this point. What we know from differentiation is that the first derivative, or this, which we got in the first part, is basically the equation of the gradient. So if I want to have the gradient at this point, which is x equals 2, I can substitute 2 into this equation here. Is going to give me the equation of the gradient, is going to give me the value of the gradient at this point 2. And this value of the gradient is the gradient of the tangent line at the same point 2. So basically the first derivative gives me the gradient of the tangent at the point x. Okay, so from here I know that this tangent is a straight line, so its equation is going to be something that looks like this, mx plus b or c or whatever. So I know that m is the gradient, so let's start by getting the gradient of this tangent over here. How will I get that? I will substitute 2 into my gradient equation, or into my first derivative. So y dash, which is going to equal to m, is going to equal 2 multiply x, which is 2 plus 3. So 2 times 2, 4 plus 3, 7. So my m, or the gradient at this point over here, is positive 7. So I know that my equation for the tangent line, so let's say tangent equation, is y equals mx, and I know m is 7, plus c. So now I just need to get c. How do I get c? This is super easy. It already gave me a point. Okay, at that point, I know that 2 and 6 lie on the tangent. So if I substitute 2 in x and 6 in y, I can find c. So y is going to be 6 when x is 2. And then I can solve for c. This 6 equals 14. 7 times 2 is 14 plus c. And then 6 minus 14 equals c. So c equals minus 8. So to write the full answer, the equation of tangent at x equals 2 is y equals m, which is 7, x, and then plus c, which is a minus 8. So plus minus 8, or basically minus 8. So this is my answer over here. Let's continue to another question. Okay, this question says a curve has an equation of this, where k is some constant. Okay, so k is just a number. Show that when k equals 0, the turning point on c has a coordinates of this. Okay, what is the turning point? Turning point is where my gradient is 0, or my tangent is horizontal. So it could be like this, or it could be like this. These are called my turning points, stationary points, critical points, or they have lots of names. Okay, so let's start by, it told me that k equals 0, so let's start by substituting 0 instead of k. So y is going to be equal to 2x squared plus 8 times 0 x minus 3. So this, I know anything times 0 is 0, so I will have an equation in the form of y equal to x squared minus 3. So this is my equation now. It tells me when k is 0, this is your equation. Show that the turning point has a coordinates of this. I know that the turning point is basically having a gradient of 0. So first let me get my first derivative, which is the equation of my gradient. So y dash is going to equal 2 times 2 is 4, x power 2 minus 1 is 1, and then differentiation of minus 3 is 0. So now my y dash, or my first derivative, is 4x. So in order to find the coordinates of the turning point, I will equate my first derivative to 0, because I want my m to be 0, and I will see at which x does this happen. So basically x is going to equal 0. I will divide 4 both sides, and I know 0 divide anything is basically 0. So I know that the x coordinate of the turning point is 0, and it matches this part over here. So let me get the y coordinate. So what's going to be the y coordinate? Super easy. If I want to get the y, I will return to my original equation. I will substitute whatever x inside to get the y. So I will substitute an x of 0. So I will have y equals 2 times 0 squared minus 3. This all goes, so I will have y equals minus 3. So my stationary point will have a coordinate of 0 and minus 3. Perfect. All right, let's continue. Let's try and attempt this question. Okay, this question tells me find the values of x for which f of x is a decreasing function. Okay, what is a decreasing function? Decreasing function is basically the interval where a function is decreasing. The function is decreasing when it has a slope of a negative value, or a gradient of a negative value, or gradient is less than 0. This is when the function is decreasing. So basically we want to find the intervals for x, or at which x's is my gradient less than 0, or is my gradient negative. So again, first we need to find f dash of x. Let's rewrite f of x as 4x plus, and I know 3 over x could be written as 3x power minus 1. This is going to make finding f dash of x easier. I'm gonna have 4x differentiation of that is 4, and then minus 1 times 3 is minus 3x, and then reducing the power by 1 is going to be minus 2. So this I can rewrite it as 4 minus 3 over x squared. Okay, so basically this is my equation of the gradient. I want to know when does this give a negative value. Okay, so what I like to do is, first I would want to know when does this give a value of 0, okay? And then I will test around those points what's going to happen. So let's say we want to find when when this will give a value of 0, because this is my turning point. So let's equate this to 0 and try and solve. So adding 3 over x squared to both sides is going to be 4x equals 3 over x squared. So I can multiply both sides by x squared, and then divide both sides by 4. And then this will give me an answer of x equal plus or minus square root of 3 over 4. And I know that square root of 4 is basically 2, so it's going to give me a x plus or minus root 3 over 2. Plus or minus because when we square root anything, it will give us a plus or a minus. It will give us 2 values. So basically what's happening here is that my gradient is 0 at 2 x values. The first x value when it's 3 over 2, the second x value it's negative 3 over 2. Okay, so let's draw a number line and check what happens when x is root 3 over 2. I know that the gradient here is 0, and when x is negative root 3 over 2, I know that the gradient here is also 0. Let's check those intervals. What happens between those intervals? So this is one interval, this is one interval, and this over here is also one interval. Because if this is 0, then it means that this is positive, or this is positive, or this is positive, or this is negative, negative, negative. So this is basically what I'm trying to see. So let me try and see what is m in this interval. So let me choose a value of x which is in this interval. I can choose any x which is a negative x less than negative root 3 over 2. I know, let's take negative 5. Okay, and let's substitute that x into the first derivative. So our first derivative was this over here. So let's try that. So let's rewrite it. F dash of x equals 4 minus 3 over x squared. So let's start getting the values when x is negative 5. So 4 minus 3 over 5, negative 5 squared. This is going to give me, if I plug it into the calculator, is going to give me an answer of positive 3.88. So basically, this interval here is positive. Okay, let's check a value in this interval. I know that in between of negative root 3 over 2 and root 3 over 2, I can choose x is 0. So let me choose x is 0 and substitute it into the first derivative. So it's going to be 4 minus... Oh, but this is super important that the question says where x is not 0. This is where I went wrong. I cannot substitute x of 0 because it will give me a math error. So, okay, negative root 3 over 2, if I change it to decimal, it's negative 0.867. And this is 0.867. If I want to choose something in between them, I can choose, for example, x equals 0.1. So let's try x equals 0.1 in f dash of x. So 4 minus 3 over 0.1 squared. This is going to give me an answer of negative 296. I care about the sign. So in this interval, the gradient is a negative value. And if I choose any value in this interval, let's choose 5. So f dash of 5 is going to be the same as this because it's basically 5 squared. 4 minus 3 over 5 squared is going to give me a positive answer of 3.88. So this over here is positive. So I know that the gradient in this interval is positive, and then it goes into a negative. So it looks something like this. So it's positive, and then it goes into a negative. And over here is my stationary point where the gradient is 0. So this over here is the same. So it was negative, and then it is becoming positive again. And over here is my stationary point. So basically, returning to the question asks, when is the function decreasing? I know it's decreasing when m is less than 0. So when is m less than 0 is basically between negative root 3 over 2 to root 3 over 2. However, x cannot be 0. So I can write the intervals as negative root 3 over 2 x, but less than 0. Notice I didn't put an equal here because that would be wrong. X cannot equal 0. And from 0, x greater than 0 but less than root 3 over 2. So this is basically my interval over here where x is not equal to 0, where 0 is not included. So this is my answer where the function is decreasing. Okay, let's take a look at this interesting question. Okay, figure 10 shows a solid cuboid with a square base side x and height h. Its volume is 120 centimeters cubed. Okay, part I tells me find h in terms of x and hence show that the surface area is given by this. Okay, let's do the first part first. So it says h in terms of x. I know that the volume of a cuboid is basically length times width times height. So it's basically x times height, which is h. So volume is x squared h. And I know that my volume is 120. So I can substitute this volume with 120 equals x squared h. And if I want h in terms of x, I can very simply say that h is going to equal 120 over x squared. So this is basically the first part. And then it says, hence show that the surface area of the cuboid is given by this. Okay, so the surface area of this cuboid is going to be what? This cuboid has 6 faces, 1, 2, 3, and then 4 at the back, 5 down here, and then the 6th one over here. So surface area is basically the areas of all those surfaces combined. Okay, so let's start by getting this area. So this area, I can see that it's h times x, so it's x times h, but then we have an identical area on the back side as well. It's also x times h, so I'll just say 2xh. And then adding, let's add this area over here. I can see that it's also x times h, so it's x times h, and I know that I have another same identical area over here, so I'll just add it or basically multiply it by 2. Okay, and on the top, I know that it's basically x times x, because if this is x, this is x, this is x, this is x. So it's basically plus x squared, and I know that I have the exact same area down, so I'll just say 2x squared. So the area is going to equal 2xh plus 2xh is 4xh plus 2x squared. Okay, now I can see that the area equation doesn't have any h variable or any h letter. So basically I need to get rid of the h, and this is going to help me a lot in doing that. So I can substitute h with something in terms of x. So a is going to equal 4x, and instead of h, I'm gonna write 120 over x squared plus 2x squared. So my area is going to equal, let me type the 2x squared first, and then plus x will cancel with one of those x's. 4 times 120 is basically 480, and I will have an x in the denominator. This is exactly the same as this over here, so we are right. Okay, part 2i tells me find dA by dx, d squared, and d squared a by dx squared. So basically, dA by dx is basically differentiating this with respect to x. So dA by dx, I'm going to differentiate this expression. Is going to be 4x plus, okay, this 480 over x, I can write it as 480 x power minus 1. So minus 1 times 480 is basically minus 480. And then times x power negative 1, subtracting 1 from the power is going to be minus 2. So this is written as 4x minus 480 x power negative 2. This is dA by dx. If I want to find d squared a by dx squared, I'll differentiate it one more time. So I'll differentiate this expression. So it's going to be 4x, differentiation of that is 4. Then minus 2 times negative 480 is basically positive 960 x, and then minus 2, subtract that by 1 is basically minus 3. Okay, so this is dA squared by dx squared. Question 3 says, hence find the value of x which gives a minimum surface area. So minimum basically is a point where it's a critical point, or a point where the gradient is 0. And it also says find the value of the area in this case. Okay, so minimum means that I need to equate my first derivative to 0. So I need to equate this to 0. So 4x minus, let me rewrite 480 as 480 over x squared, and then I will equate it to 0 and solve for x. So 4x equals 480 over x squared. I can multiply x squared both sides. This is going to be 4x cubed equals 480. So x cubed equals 480 over 4, which is 120. So x equal cube root of 120, because I will cube root both sides. These are going to cancel. So x is equal around 4.93. And never forget the unit. Is it in centimeters? Let's check. Yes, everything is in centimeters. So this is going to be 4.93 centimeters. So this x will give me a critical point, will give me a gradient of 0. So at this x, the gradient is 0. It could be like this, or it could be like this. Those are both 0. So till now, I don't know if this is a maximum or a minimum. To make sure, we need to do the second derivative test, where we substitute our x in the second derivative, and if it's a positive value, then it's a minimum, and if I got a negative value, then it's a maximum point. So let's try and do that. So 4 plus 960 over x cubed. So my x was, the x that I want to test was 4.93 cubed. So I know that 4 is positive, 960 over 4.9. So basically this is going, at the end is going to give me a positive answer. So I know that it's a minimum point. So this x is going to give me a minimum area. Okay, and it says find also the value of area in this case. So this is super easy. I will just substitute my x value that I got in the area equation over here. So my area is going to equal 2 times x squared, 4.93 squared, plus 480 over 4.93. This is going to give me around 480 over 4.93 is going to give me an answer of let's check, 100, around 146 centimeters squared. This is correct. Perfect. Right. Okay, let's try and attempt this next question. Okay, please guys, if you find this video helpful, don't forget to like and subscribe, okay? And please go watch the previous videos, as this gives me so much motivation to continue. Okay, so the curve C has an equation of this, where A and B are constants. So I'm not given the full equation. I have some variables or letters that I don't know. It says the point A with a coordinate of 2, minus 6 lies on C. So I know when x is 2, y is minus 6. And it also gave me the information that the gradient at A, or the gradient when x is 2, is basically 16. And it wants the y coordinate of the point on the curve where x is 3. So if I had the full equation, this is super easy. I will just substitute this 3 into the x's over here, and then it will give me the y. The problem is that I don't have A or B. So I need to get A and B first. So let's try and do that. Let's start with this first one over here. So it tells me y is minus 6 when x is 2. So let's do y equals so y is going to be minus 6 equal A times 2 cubed plus B times 2 squared minus 12 times 2 plus 6. So minus 6 equals 2 cubed is 8, so it's going to be 8a plus 2 squared is 4, is 4b. Minus 12 times 2 is minus 24. Minus 24 plus 6 is minus 18. So I know that 8a plus 4b is equal to, I can add 18 to both sides, so negative 6 plus 18 is basically 12. So this over here is my first equation, okay, with two variables. So if I have another equation with those two variables, I can solve them simultaneously to get what is A and what is B. So let's do that from this second information we have here, that the gradient is 16. I know that the gradient is 16, so y dash is equal to 16 when x is 2. So let me find the expression for y dash first. So y dash is going to equal, is basically the differentiation of this expression. So 3ax squared plus 2 times b is 2bx, and then minus 12x is basically minus 12. And I know that when x is 2, y dash is 16. So 16 equals 3a times 2 squared plus 2b times 2 minus 12. So I will have 16 equals 2 squared is 4 times 3 is 12a plus 2 times 2 is 4b, and then minus 12. So I can add 12 to both sides. So I will have another equation which is 12a plus 4b equals 16 plus 12 is 28. So this is my second equation. Let me try to solve them simultaneously. Right away, I can see a 4b and a 4b here. So I can solve using elimination. I will subtract both of them from each other. So 8a minus 12a is minus 4a. 4b minus 4b is 0, which is what I want. And then 12 minus 28 is minus 16. So a is minus 16 over minus 4, or basically equal to 4. So this is a. And if I want to get b, I will substitute a in one of the equations. So 8 times a, which is 4, plus 4b equals 12. So 32 plus 4b equals 12. So 4b equals 12 minus 32, which is minus 20. So b equals minus 20 over 4, which is equal to minus 5. So my a is 4, my b is minus 5. Let me rewrite this equation. So over here, y equals a, which I got as 4 x cubed, plus b, which is minus 5 x squared, minus 12 x plus 6. The question wants the y value when x is 3. So y equal 4. I will substitute 3 in all the x's. Minus 12 3 plus 6. So this is going to give me an answer of squared minus 12 times 3 plus 6. That is going to give me an answer of 33. So my y is going to be 33 when x equals 3. And this is the answer to the question. Okay, let's take one more question, which is super interesting as well. For applications of differentiation. So a company manufactures food tins in the shape of cylinders, which must have a constant volume of 150 pi centimeter cubed. So we have some tin cylinders. So this is a cylinder, and I know that tin cylinder is basically a solid cylinder, or it's a closed cylinder. Okay, so it says that the volume is supposed to be kept at 150 pi centimeter cubed. Okay, so it says to lessen the material, the company would like to minimize the surface area of the tin. So the surface area of the tin is composed of 3 surfaces: this top surface, this top circle, this bottom circle, and this curved surface, okay, which is the third one. Okay, so by first expressing the height of the tin in terms of the radius, show that the surface area is given by this. So let's say this is the height, h, and over here, so from here to here, this is the radius, let's call it r. Okay, so it says express h in terms of r. So I know that the volume of this cylinder is going to basically equal pi r squared h, or it's basically the cross-sectional area times the height, or you can use the formula books to get those formulas. So I know that instead of volume, I can write in 150 pi, because the volume is equal to 150 pi. So this is equal pi r squared h. I can cancel off 2 pi's, and I can divide r squared both sides. So 150 over r squared is going to equal h, and this is my h, basically my h in terms of r. Okay. It says show that the surface area of the cylinder is given by this. Okay, so the surface area is basically the addition of those 3 surfaces. So the first surface, which is a circle, which is equal to the second surface, is going to have a surface area of, I know that the area of a circle is pi r squared, and then I have another surface which is pi r squared. So basically these are the 2 surfaces. So this is the total surface area, is the top circle plus the bottom circle plus the curved surface area. So this curved surface area, which is shape 3, has a formula to find the surface area of this. It's basically 2 pi r times h, or basically it's 2 pi r, which is this circumference multiplying this height over here. So I will add a 2 pi RH, which is the area of the third surface, and I can see that I don't have any h over here, so I can substitute h with 150 over r squared. So s equals, let's combine these two, is going to be 2 pi r squared plus 2 pi r, and instead of h, I'm gonna write 150 over r squared. So I know from here, I can have this r cancelling with one of those r's, and then I will have this equal to 2 pi r squared plus 150 times 2 pi is 300 pi, and then 1 r is cancelled from here, so 1 r is left, and this is exactly the same as this over here. The second part of this question says use calculus to find the minimum value of the surface area of the tins. Give your answer to 2 decimal places. So if I want the minimum value, again, I will need to get the first derivative and then equate it to 0. So let's say we want to get ds by dr, which is a derivative of s. So this is going to equal 2 times 2 is 4 pi r, and I can rewrite 300 pi over r as 300 pi r per minus 1. So if I want to differentiate that, I'm going to multiply minus 1 times 300. It's going to be minus 300 pi r, and then minus 1, I will subtract 1, is going to be minus 2. So this is basically the first derivative. If I want this first derivative, I can equate it to 0. So I will have 4 pi r minus 300 pi. I will just rewrite this as over r squared, and I will equate it to 0, and I will try to find at what r does this give me a gradient of 0 or a critical point. So I can add 300 pi over r squared to both sides. So this is going to give me, I can multiply r squared to both sides. So this is going to be 4 pi r cubed equal 300 pi. I can cancel out those pi's, and I can have an r cubed equal 300 over 4. And now r equals cube root of 300 over 4, because I can cube root both sides. This is going to give me an answer of over 4. So it's going to give me an answer of 4.22 centimeter for r. This is a critical point. So at this r, my gradient of the surface area is 0. I don't know if it's a maximum or if it's a minimum. To check, I will need to get d squared s by dr squared. So let's get that quickly. So it's basically differentiation of this expression over here. So 4 pi r is going to be differentiated to 4 pi. And then minus 2 times minus 300 is plus 600 pi. And then r power minus 2 minus 1 is basically this. So if I want to check my value, is it going to give me a minimum or a maximum, I will need to substitute into the second derivative, and if it gave me a positive value, then it's a minimum. If it's a negative value, then it's a maximum. So 4 pi plus 600 pi times 4.22 or negative 3. If I substitute that, I already know it's going to give me a positive answer, which is 4.22 power 3 is going to give me an answer of 141,669.7 or whatever. I don't care about the number. I just care that this is a positive value over here. So this r value is a minimum, is going to give me a minimum point. And it says find the surface area or the minimum surface area. So basically, I will just substitute my r value that I got, okay, in the original surface area equation. So it's going to be 2 pi, and instead of r, I'm gonna write the value that I got, which was 4.22. 4.22 squared plus 300 pi over 4.22. This is going to give me an answer of 300 pi over 4.22 is going to give me an answer of 335.2 centimeter squared, and this is going to be my minimum surface area for this question over here. I hope this was helpful. Please don't forget to comment, like, and subscribe. Turn on the notifications so you're notified whenever I upload a video. Thank you so much for watching. If you want a part 2 of this where I solve more applications of differentiation, please let me know down below. And thank you for watching. Have a nice day.